Hello there, everyone. Right, today we are meeting with another topic in EGD, right, that is isometric drawing. Right, we want to look at this as a revision exercise. Remember, we have been looking at mechanical analytical, but now we want to switch to isometric since we cannot do assembly in an hour. We want to make sure that we reserve the 2 hours for assembly drawing so that we are able to get everything that we want from those 2 hours. So I want you to enjoy this lesson, look at everything that we are doing with regards to isometric so that you perfect your art of drawing in preparation for the exams. Like I said, it's isometric drawing. All right, we are going to look at question 3 of paper 2. Right, this is a revision exercise, and we are looking at a past exam paper, which was for November 2018, all the approaches and application. That's what we are going to focus on so that we are able to see and capture everything, recap on whatever we have done so far with regards to isometrics, so that we are able to practice on our own, apply the concepts, and focus on our preparation with regards to the forthcoming exams. As always, right, I hear and I forget, I see and I remember, I do and I understand. That's the thrust with regards to EGD. We want to make sure that you are able to do it on your own, right, independently, right, without any assistance. That can only happen if you practice, if you are able to apply the concept that we are going to look at today. Enjoy the lesson. Good day. Right, like I said, we are going to look at question number 3, which is the isometric drawing. Right, so this is what you would find normally in terms of the information. Let me just bring this one down so that you would see exactly. Right, like I said, it's 2018 paper. Right, given the front view, which is this front view, right, so the top view, which is this top view, and a left view, which is that. The position of point S on the drawing paper, right, we've got point S, we've got point S, we've got point S. Right, normally point S is regarded as the lowest point in terms of your isometric drawing. It can also be regarded as the closest point to the observer. So it will be the point which is closer to you as you are looking at the isometric drawing. Right, instructions. Using scale 1:1, convert the orthographic views of the bracket into an isometric drawing. So we want to convert these views. Remember, when we are looking at orthographic projection, be it first angle, be it third angle orthographic projection, we convert the 3D into two-dimensional views. Now we want to convert the two-dimensional views back to 3D. Right, so make point S the lowest point of the drawing, show or construction, no hidden detail is required. Right, so now we have got the information with regards to what is it that we are supposed to do. Right, the first thing that you check, it says placement plus auxiliary view. Right, okay, so what it means is that at some point we might need to establish an auxiliary view. Right, an auxiliary view is basically a view that would help you construct other views. Right, so it will be the true view. Remember, we are going to present the object in isometric. Right, pictorial views by nature would have some element of distortion here and there in terms of the size, in terms of the angle at which you are looking at the object. So we want to make sure that we create an auxiliary view that would enable us to be able to come up with the necessary views. We also want to draw the front portion, the back portion, and we look at the circle construction, right? The circle itself and the way or the method that we use in order to construct that, right? So whatever you do, do not lose sight of the marking assessment or assessment criteria. That is important so that you know whether what you are doing is answering the question. Sorry about that. Right, so the first thing that we want to do, right, is to create an isometric box. Right, one thing that is critical in the creation of an isometric box, we see we have got a left view. So the left view should be seen from the left as well. So the placement is critical. So what we do is we take this size, which is 30 plus 30, which is 60 plus 36, which is 96. So we measure 96 on this side. Right, accuracy is very important. Like that. Then we have got our length, right? Our length is defined by 20 plus 42 plus 38, right? Which means we are going to get 80 plus 20, which would give you 100. So we measure 100 here. We will draw a faint vertical line. Like that. Then we need our height from here to there, that's 76. So we measure from here. Right. So we have created our isometric box, right? So this is the equivalent of space calculation in mechanical drawing. So whatever we are going to do should be able to fit in this box. Then once we have done that, you then look at the detail or, right, the detail that is easy to start with or that is you are certain to draw. Right, let's look at this part, which is from here to there and from here to there, which would constitute that one in terms of our top view. So we have got from here to there, that's 26. Let's measure 26. Then with that 26, from here to there, that's 22. Remember, at each and every point that you have created, there should be 3 lines, one vertical, one to the left, and one to the right. Right, from here to there, that's 24. So we measure 24. Right. If you've done this, the next thing that you want to do, right, you can actually outline this, but it's not going to change. And the vertical line, which is this one. There you go. Right. That is your first detail. Right. With regards to this part, from here to there and from here to there, the same applies that part, which is that one. Then the line which goes all the way to the bottom can also be defined like that. Right. The next thing, you look for other details. We can see, right, from the front view, right, the height from here to there, right, which is this part, right, it's 38, which is a half of 76. Right. So what we can do, because we would need this, we can also do this, draw a line like that. Right, this should also give us 76, right, which is exactly that. Then we also take this one down. Like that. Right, so we have got from here to there 76, from here to there 76, and also from here to there. That is what we refer to as an isometric square, okay? Right, then the other thing that we need, right, we can basically construct a diagonal from here to there to get to the center. Remember, in isometric, you limit measuring as much as possible, such that you basically have to draw everything by reference, okay? So the distance from here to there and the distance from here to there should be 38 by 38. Let's just verify that, which is exactly that. Which is exactly that. Right, so now we have got our center there, right? Now we can see that there is a circular cut here, right? So standing here, right, we can also be able to draw an arc, right? If we bring this one down, we bring this one down here. Always start with the obvious detail. Okay. Right, so we have got this part, okay? Remember, it's circular, right? From here to there, but there is a gap there, so we are only going to see that, which is a reflection for that part only. Right, once we have done that, we can even bring our set square, right, and complete this line. Like that. At this point, we can also take this one there. Right, we know that this part from here to there, it's 18 millimeters. So we can measure 18. Right, when we take it down, like that. Right, we need to measure from here to there. It's 24 millimeters so that we get this height, right, from here to there, which would take us to this, so that we are able to complete that part. So let's measure 24. Right, the end result is that now we are able to take this one all the way. We might need it. Like this. Then we also take it this way. Remember, the idea is not to continuously measure. So we can outline from here to there, we can outline from here to there, but here we would stop. Right, let's do this. Also, draw a line like that, okay? Right. Which would give us the distance from here to there, that's 24, right? We outline from here to there, we outline from here to there, but every detail that has been defined, we can outline that. So we come here for a line like this. Right, there's nothing that would stop us from outlining from here to there, right, which is the 18 millimeter. Right, and also the vertical line with regards to that. This one too. Right. Remember, you should be able to understand the diagram before you start drawing, okay? Right. We need from here to the 18 millimeters, okay? Right, such that we can connect this lower point to there, we can connect this one to there, and we can bring this one there. Right, so what you do is you don't need to measure as long as the distance from here to there is 18, right? Just extend this line, right? Automatically the distance from here to there should also be 18, then you bring it back like that. Right, so the distance from here to there is also 18, then we can connect this and connect this one as well. Right, you do the same. So we can outline from here to there, we can outline this, that part, and that part as well. So let's start by outlining from here to there. Remember, there are three things which are key in drawing. That is your presentation in terms of neatness, that is your accuracy, and your speed. Right, you should be able to do your work quickly, right, but neatly as well as accurately. Right, do not always rely on an eraser. Like that. So we are done with this part, which is that one. We also looked at the top part like that. So we can also go forward, right? Let me extend this. Right, we measure, we can see that there's a gap of 18 millimeters here. So we can measure. Looks like it's already there. Okay. So we can proceed with this. The moment you get this one, you take it up like that. Right. Remember, from what we are able to see, this level is the same as that one. So we now have got this part from here to there, right? Which is basically the 18 millimeter line. Let me just verify something. It's 18. It's 22. Right, that's 18. Right, that's 22, which is from here to there. Right, we need another 18 from here to there. Let me take this one. That's oh yes, slightly off. Right, slightly off. So we need this one slightly above, like that, okay? Right, so that's from here to there, that's our 18, right? It's slightly to the left, right, okay. So what it means is that if we bring this one down and we take that one, that detail can easily be outlined, okay? So we can take this. Like that. And also outline this particular detail. Like that. Then this part, right, which is the line from here to there, can easily be outlined all the way. So we can outline this. It's not going to change. then it is stopped here. Right. Remember, you deal with the obvious lines, right? Any line that you are able to see clearly, that's what you deal with. Right. Then from there, what we are done with, right? We are done with this part. Okay. Right. The next thing that we want to look at, right, is this detail here. Right. So we go to the left-hand side, we measure from here to there, 25, which is the 25. We measure from here to there, 40. Right, let's do that. So the first thing that we want is 14, like this. Then we also have got 25, which is that, which is our 25. We join this to there. And this line can now be outlined. It's not going to change. The moment we have outlined that, right, we can also now outline this all the way, okay? So we come here, always deal with the obvious lines, right? As you are dealing with that, your mind is constantly looking also to solve other scenarios or other problems, right? We also come here, like that. Then at this point, we can create isometric lines. But we know that from here to there, right, which is that part, from here to there, that's 20 millimeters. So let's measure 20. Right. Then we create an isometric line. Like that. Right, after the 14, we have got a 34. So we measure 34. Like always, every point, you take it down. Like that. Right, at this point, we can outline this. We can also outline this. Right, there is nothing that will stop you from outlining this one as well. Always, you start with the obvious details, the ones that you can easily construct. Right, we need this from here to there, which we find it's 15. So we need to measure 15. Which is here. Right. But we need to take this one back. Right, and we can see that this point is in line with that, so we don't need to worry about that. We take this one like this. Right, so there is the point, which is the same point as that. Right, is the same level, right, that so we are going to come to this point. Right, then the other thing, we are also given from here to there, that's 38. So we need to measure from here (38). We take this one up like that. Let's outline what we have now. Right, we can outline this. right? We can outline the 15 millimeter mark. This one. Next, we can check this one now. But that part is defined. So when we are looking in terms of the front view, looking from this direction, that is the part that we'll be able to see. Right. Then the next thing, right, of course, we needed also to outline this. Right, and we outline. Remember, we said this is 38 from here to there. Right, which is 38. So we can outline from here to there. Like that. Right. Remember, at each and every point that we have defined, you need to create a line like that, a line to the left, a line to the right, and a vertical line. There should always be 3 lines at that particular point. If we project from here, right? If we project from here like this, right, you will end up being able to see, right, this part, which should also be 20 millimeters, just to verify, and you'll be able to see that should still give us 20 millimeters like that. Right, so then project it like this. Now, that detail is not going to change, right? Whatever we do, it will remain like that, so we can easily outline this. Remember, you start by working with the obvious detail, okay? What you are able to see. What you are not sure about, do not outline. So we have got that part. Then the next thing, right, we want to define this one from here to there. We measure from here to there, that's 15, okay? Right, so what we basically need to do, right, at this point, we need to measure another 15, going downwards, like that. We have this, okay? Right, we can also now project this one in this direction, like that. If we take this, we take it there, right, we project it to the right. We should also be able to take it down, and we create also that 20 millimeter. So from here to there, it should also be 20 millimeters as well. Right. Then at this point, we are told that from here, from this point to that point, which is this point to that point, should be 10 millimeters. And the other point from here to there, right, should be 12 millimeters if we take it from the top view like that. But let's just check. Right, so this is perfectly 10, right? So automatically the other distance from here to there, right, should give us 12 millimeters, which is exactly that. Right, okay. Now, we also know that the height from here to there should be the same height, okay? So by projection, we can go and establish this. Then we take it also to this side, okay? We do this, right? So the same height, right, from here to there is the same, which is that one, right? So what we need is also the 20 millimeters, all right, from here to there, So this one we can take like that, which is that part. Then we can bring this one back like this. Okay, right. So the platform at the top, right? The platform at the top, from here to there and from here to there, that part, which is this part, which is also the same part which we are able to see, which is basically in line with that. Right, so this can now be connected to this point, and this one be connected to that point. Right, let's do that. There's quite a number of lines that we can outline at this point. We can outline this all the way to there. Right, we can also outline this, right, like that. Then this to the right. This. Take it all the way to the end. Then we can also define this. Right. But what we cannot outline is that part which goes down, which is that part. We need an auxiliary view in order to define that. So we are only going to define or work on that which we are able to see clearly for now. We do this. We connect this one to there. Slowly, our isometric drawing is taking shape. Right, okay. So we have got all that, right? So we need this part which goes down, but that can only be defined by an isometric view, by an auxiliary view. Right, we know in terms of that level, right? That level is 19 millimeters. So let's measure that 19 millimeters from the base. We can come here. Right, we measure like that. Then we project it here. Right. Then we take it like that. So that is the level that we want in terms of the height from here to there. But what we don't have is the distance from here to there. Right? That would come about as a result of having drawn an auxiliary view. But what we are certain is we can be able to define this going downwards, so from here to there. Right. So we now wait for the auxiliary view in order to define that. So let us draw that auxiliary view. So we start it somewhere here. Right. We have got this measurement. We have got the 20. We have got the 42. Right, because the angle is drawn at that, right? And the height that we want, it will be 76 minus 19, which would give us 57. Let me just make this one higher. Like this. Right, okay. I want to draw the real thing. Remember, we can just create something, but I want to draw the actual shape that we'll be able to see. Right, so we have got 20 and 42. We have got the height of 57. That's so slightly. So we draw a line like this. Right, this is our 20, right, and this is our 42. Right, then we take our 42 like this, then we draw a line. Right, so the distance that we want is from here to there or from here to there. Right, right, if we take this one from here to there, right, this is the one that would measure here, then would connect with the other details in terms of the center lines like that. So let's check if we are able to measure from here. Right, it's basically 9 millimeters. So I can come here and also measure 9 millimeters like this. Right, okay. So that is the extent of that part going downwards, okay? Right, so you find that we'll be able to draw from here like that, right, going to the other side, right, and we might be able to see that detail somewhere through like this. Right, okay, so that is the line, and we are also going to see, partly we will see that line there, all right? But before we do that, let us also define, right, define the other parts which are here. We know from the end we need to measure. We need to measure 30. We also need 30 there. So we take this. That's your 6. That's your 30. Okay. We might need it for reference. This is already there. Okay. Take this one down. We also need to take this one down like that. We need this point. Like this. We also need this one like that. Right. Now, by projection, right, because we have got our center here, right, we also need to establish this point, which is our center as well, right? And we also, if we continue with this, like that, right, that would also be our center point, okay? Then we take this one halfway, right? We've got this to that. But from here to there, that's 38. So we need to measure 38. Right, of which that 38 is already there, right? Because we have got from here to there, that's 38, right? And from here automatically to there, that would give us another 38 as well. So we take that. So at this point, but remember from here to there, that's 38. At this point, we connected this line to there. Right, that is our 60-degree angle, but we connect like this. We have created an angle of 60 degrees. All right, the moment we have created that, automatically it would hit this line here. Right, it would hit this line here, and we take it to the other end, like this. Right, it would also now connect with this one, with this point, which is the same as connecting from here to there. If you do this, there is a platform, which is the level platform from here to there, right, like that, coming to here, right? Then we also need this one. So what we need to do, we need to take from the 19, we go to this side, right? We look for this point, which is the same as that. We also connect with this. Like that. Right. So we now have got our slant sides, right? This one is coming down like that, right? So that it hits this line at that point, then we take it there. The moment it hits this line here, right, we take it, then we bring this one down, we take it there. The moment you have that, so we have got a slant side, okay? All the way that we'll be able to see. But we can only outline from here to there, right? From here to there, and that part, this one, that one, then we would need a curved part, something like that. Right, okay? Right, so remember, always, always, always define the details that you are happy with. So we can outline this, right, up to this level. Right, up to this level, we can take this one now. Outline from here to there. Right, we can take this one as well. Then project. Right, this can also be defined. Right, in line with that. Right, so what we want at this point, right? What we want at this point is to make sure that we are able also to create an isometric box, right? We are also able to create an isometric box, right? Which is from here, right, all the way, but we can do that. Remember, this is take this one all the way to that point. We locate this point. Take this one down. Like that. Right. But so we have got an isometric box from here to there, from here to there, from here to there. That would be 76. Let's just verify. That's correct. That's 76. All right. And also this one should be 76, that's fine. Right, now, what we need, right, we need a center line. Right, let's just connect like this, though not so useful at this point. Like that. So we know that our center line is from here to this point, okay? Right, and also from here all the way to there, right? So we can stand at this point, open your canvas. It should touch there, which is perfect. And we describe an arc, but it's going to be stopped somewhere in the way, like that. Right. So that is the part. Remember, you stand here, right? You connect with this point, you also connect with that, you have got that part. Right. The next thing that we want now is also again, but using the same platform, right? We extend, we get to this point, right? And this is our center. Right? So we bring this one down. Like that. We project from here. We get that. We can also connect like this. We bring this one down, which would give us that, okay, that point. Now we need to create a diagonal here. Here it's required. Create a diagonal like that. Right. Then through the center, we have got our center there. Then the other one would be here. We connect. This is the point. We connect like this. We stand here, open to this point, which is the same as this point, which is the same as that one. So you have got that. Then we describe an arc like that. So we have got that. Then we need another diagonal. So we are simply going to project from here, extend this one all the way. Then you get to this point. It's also 76. Then you take this one down, right? We get to this point, right? We connect. Right, we connect with that one. With this one. Like that. But we are not going to draw everything, but we are just going to transfer this center that is already established. We do this, we get this particular center. Right, we stand there. Right, we stand there. Open to the radius, which is there. Sometimes you just need to adjust a little bit because these are constructions. Then you describe only up to the diagonal like that. You don't go beyond the diagonal, but such that, right, you can take your 30-60 degree set square. If you are accurate, this should give you one and the same line like that. Then we can outline this. Like that. Right, slowly taking shape. Right, once you have done that, right, you have got this detail. You can also outline this. Right, this is that corner that we are able to see. Right, and you can bring this one now to there. You can also connect this one to there, but not outline it all the way. Like this. Right, okay. Right, then remember at some point we were saying that we should be able to see this detail, right, all the way, and wherever we are able to see it, so we do this, right, and we'll be able to see it partly here, like that. Then there's this edge, all right, that edge, we should be able to see it just here, okay, just there. That particular edge, right, if we are saying this surface, right, that is the horizontal surface in terms of that groove that we have created. Just want to give an artistic impression of this. Remember, don't do this in an exam. There are no marks for doing this. I just want you to be able to see. Right, okay. Right, that is the grooved part. So would you still see that part here? So I'm going to come here as well and do the same thing, such that you have got a picture. So this part is the same thing. So we see it here, then we see. So this is a raised part which would accommodate that. Now, once you have done that, the next thing now is to define the center lines everywhere. Where there are center lines, you would need to show. Right, let's take a red pen, right, would come here and show the center line, right, would also come here and show center line, then also here, center line, right, unless they are stopped by, that's a center line as well, okay? Right, where else do we have the center line? Right, so that's about it. Right, in terms of the center lines, we have got everything that we require. Right, this is it. Right, so this is a typical example of how you would draw an isometric drawing given the various views and information. Right, remember, the whole idea is to make sure that you are fast, you are accurate, and you are neat. As you can see, mostly I draw with a pen, but that can only be possible if you know what you are doing. So I want you to get to that level as well, whereby you would know that you are not going to rely on an eraser in order to come up with your drawing. Thank you. I hope you enjoyed this lesson, and we hope to see each other again when we look at another example of isometrics. Like I said, we are going to reserve our assembly drawing to Saturdays, where we have got two-hour sessions. So I'm going to just write here. That is our auxiliary view, okay? And that is our isometric drawing. Thank you. Enjoy the rest of your day. Goodbye.